guys? Hope you guys are doing okay. And let's get to it. We're going to talk about time and keeping time with our code. One of the things this allows us to do is to evaluate how efficient our code is. It's called profiling, and that's in the book. You can use it to profile code. That is to measure how long a piece of code takes to run. So the Unix Epoch is a time, like it says here, 12 a.m. on January 1st, 1970, coordinated universal time. What that, and I don't know why that's the date, that's just what it is, but this time.time returns the number of seconds since that moment. So we have, when he ran this, whenever he did it, so he did it a year and a half ago, give or take. It had been that many seconds since that day, 12 a.m. in 1970. So what you can do is you can use this to see how efficient your code is or how long it takes to run. I have copied and pasted this. What this section of code is doing is it's finding the product of every number from 1 to 100,000. So that's 1 times 2 times 3 times 4 times 5 times 6 times 6 times 7 times 8 times 9 times 10 all the way to 100,000. That takes a long time. According to his computer, he did it in 2.84 seconds, and that digit is nearly half a million digits long. So let's see what happens when I run that same code. So here it is. I've copied and pasted it. So here we go. Import time. Time you have to import. Obviously, it's a module in order to allow us to do this. And then it calculates the product from the first 100,000 numbers. Product is 1 for I in range 1 to 100,000. Product is product times I. So that's 1 times 1, and then 1 times 2, and then 2 times 3, which is 6, times 4 is 24, times 5 is 120, and then 120 times 6, and then all that all the way up to 100,000, and it returns the product. Now this is where we start using time right here. We have start time is time.time. We have our product, which equals the returned value of whatever this number is. And end time is time.time. So basically we start the stopwatch, we run the code, we end the stopwatch. And the result is %sign s digits long, and it is a string version of that number, and we get the length of that number, the length of the number of string, a number of characters in that string, and then we figure out the end time. So we subtract the end time, so we subtract the start time from the end time, and that gives us how long it took. So let's start with 1 to 10. That takes 10 thousandths of seconds, or tens, 100,000. That's like a millionth of a second to calculate. So if we do 1 to 100, y is, okay, I don't know how it does it in 0 seconds, but $1.2, so that's for 10,000. For 100,000, I've already ran it. It took 23 seconds. So this dude is working on a much higher computer than, higher process, much faster computer than I am. So that is how we figure out how, one way to figure out the efficiency of our code. Another thing, so if it just gives us seconds, right? So let me, that's just a number to me. I don't know what that means. I don't know what date that is. I don't know anything about it. But if we do time.time, that gives us the current time since, well, that just gives us the current time. We could also do now time.time gives us the same thing. What he did here is he did time.ctime, gave us the time, and then you do this moment. So if I do this, wait, moment is time.time. So it's So it's going to be 8:36:30 something probably. That's what this moment is. So if I do .31, so I can save a date, I can save a time. You know, this program was last run at this time. So if you want to, if you have a code that is dependent on a certain time, you can have, you know, you don't want it to run but until 4 a.m. You can have it check what time is it, what time is it. Once it's 4 a.m. on a certain date, you can do something. We'll get into a little bit more how to do that, how to actually launch the program at 4 a.m. But yeah, you can also have it check. You can have a record, so you can write stuff to a text file. Say this program was last launched at this time. So it's pretty cool what you can do with this. I think you guys are all familiar with the time.sleep, so you import time. Already did that. So time.sleep and then 5. What it will do is it will pause my program for the number of seconds in here. You can do decimals. That works too. So this is a good way to essentially have a countdown clock. So for I in range 60 to 0, print I time dot sleep 1. Oh, because I forgot. So again, just something I forgot. 60 to 0, you have to tell it you're going backwards by 1. Otherwise, it goes 60 to 0. There's no numbers in between that range. Boom. Because you can't start at 60 and you can't increase and ever get to 0. You have to give it the little -1 so that it knows to go down. How long is this? 7 minutes. Okay. The last, well, maybe not the last thing. Rounding numbers. So if you ever just, so if you ever just want to round a number, you can, if it's $15 and your math comes out to 56 cents, you can round it to 16. Or if you put a decimal in there, it will round it to your cents. So if you're doing math and you have, you know, something costs $15.65 and there is a 0.0825% tax, but we obviously don't do that, so we would round. We don't have fractions of a penny, so we would round it, darn it, to 2. 1.29 worth of tax. So this is pretty easy. I mean, I don't think I need to go over this too much. You could do round this moment, so it's been that many seconds. But if you want decimals, you just add a second parameter. And apparently, yeah, there we go. Okay. And then you guys did that. I'm gonna go over the date time module real quick because, and the time delta, because multi-threading. Oh, okay, no, I'll go over that later. The date time module. So what this does is date time. So we have import date time. What this will do is this doesn't give us seconds, but this allows us to put numbers to dates and dates to numbers. So if we do date, I'm actually going to do as dt because I date time dot now. So this will give us the date as a year, month, day, hour, minute, second, millisecond. So we could do date equals dt dot date time, and we could do 1999 month, day, 11, 59. So this is, I don't know if you guys know, but this is the second before Y2K. People kind of freaking out that the 2000, the 000 into the 2000 would actually crash computers. Obviously it didn't, the world kept turning, but there was a huge, like, it's the end of the world type thing. I barely remember it, but anyway. So we can't, so this is date, right? So this is our date time object. What we can do is do date dot time, not time, day. 31st, date dot month, 12, date dot year, all that sort of stuff. So you can break it up, and they've set it up to where this is time, I'm sorry, this is year, this is month, this is day, this is hour, this is minute, this is second. I'm sure there's actually a millisecond one. Date. Uh-oh, maybe not, maybe I don't know what I'm talking about. There we go. So minute, microsecond, 0, because I didn't give it one. Micro, not millisecond. So that's how you use date and time. Now, what is this? From timestamp. Oh, so this allows you, I forgot. This allows you to, from a certain time, add 100,000 seconds or 1,000,000 seconds. So you can use date time from timestamp 1,000. That will pass 1,000. Oh my gosh, my voice. It'll pass 100,000 seconds to from there. I just have something in my throat. That's it. Nothing else. It'll be, yeah, so let's just watch this. So we got that. So date, we have dt dot date time dot from time stamp. And if we do 10, 1916. That's the wrong time. The Unix Epoch, 12 a.m., January 1st. This is giving me that's 6 p.m. This is weird, guys. I don't know why that's not the right number. Because if we do this, how many numbers is this? 1970, 1, 2, 5, 4, 6, 40. Huh. So we're off by 2 hours. At least 2 hours. I don't understand. Well, and then I guess we can do time.time. And that gives us day, year, month, day, hour, millisecond. Yeah. So that gives us the current. Don't use from time. I'm never going to ask you to use from timestamp. Forget that. So right here, I'm going to stop at the time delta. So we're just going to do this right here. You can create your own day. So if you have a special day, we're going to follow Halloween. Halloween 2019 is dt.datetime 2019 10 31 000. That's midnight 000. So boom, You can do the same thing. I'm not going to copy all these. Here's New Year's. And then October 30, whatever. Oh, no, we'll do this. And here's October 31st. So you can evaluate whether or not two things are the same time. So we could do Halloween 2019 equal October 31, 2019. We'll get it true because those are the same time. If we had changed even just this 1 microsecond, it's false. So it has to be the exact time. It can't be, it's not the same day or month. It has to be the exact same time. Now you could do, hang on, let me get rid of this. Let me redo this one. We'll change this to 1. Let's just verify that it's false. False. But if we do day, that's going to be true because it's going to evaluate the day here between Halloween, which is 31, and October 31st. Even though the microsecond's different, the day is still the same, so that's okay. I'm going to change this back to, so that's the exact same. And then we do New Year's equal October 31st, 2019. That's false. We can do doesn't equal, and that's true. So what you would use this for is the current time this special time that I want this code to run? If it is, run it. If it's not, don't. So you could do something. So special is let's make this 2020. We're just gonna say this upcoming Halloween is special. So you could do if time.time. No, I don't want that. Time.ctime, because then we can actually read it. Equal special print yay else print nay. And so we're going to go over multi-threading, so you can have code, you can have actually two separate sections of your code running at the same time, but we're not going to go over that today because otherwise you would have to have it check. I'm not going to get into that. This didn't go because so as long as it doesn't equal, yay, then we get an infinite loop. But you can actually have it while true, check every second, and while it's checking every second, it's doing other code. So we're going to get into that. But for now, I just want you guys to go through this. I'll put your guys' assignment online. Otherwise, hope you're having a good day, and I'll see you tomorrow. Well, maybe. I'll talk to you later. Bye.